Welcome to My Dreamz Academy. Today we will discuss in physics class motion in a straight line. Okay. So this belongs to kinematics chapter. Kinematics. In this first chapter is motion in a straight line or one-dimensional motion. Simply we can write 1D motion is also 1D motion. Motion in a straight line or 1D motion. So motion in a straight line means the body is moving along the straight line. The body is moving along the straight line. So now in this we have to discuss 2 points. First one is distance and displacement. So first one is distance and another one is displacement. So what is the difference between distance and displacement? Distance means the total path length. The total path length. Total path length is called distance. Total path length. Okay, the total path that covered by the body, that is called distance. So displacement means the total path length. So the total path length is distance. Displacement means the shortest path. The shortest path or the shortest distance between the shortest distance between initial and final positions. Initial and final positions, that is called displacement. Distance means the total path length covered by the body, that is a distance. Displacement means the shortest distance between initial and final positions, or the shortest path distance between initial and final positions. So anyway here distance is a scalar. Distance is a scalar, displacement is vector. Now what are the units of this distance? That is a meters. SI units meters. Here also distance, displacement units are meters. Okay, so the major difference is the shortest distance, that is a displacement. Now the total path length, that is called distance. So anyway distance is a scalar, displacement is vector. So both has same units, that is a meter in SI units. Okay, let us see some examples. So what is the difference between distance and displacement? How can we measure the distance and displacement? Now for example, consider one problem. A body is moving from A to B. A body is moving from A to B. From A to B as shown in graph figure. Right. For example, this is the initial position. Now start at this point. Body is moving along this direction. Finally, it reaches this point. Now this is a body is moving from A to B like this. Now this is the initial position. This is the final position. What is the distance and displacement? Distance means the total length or the total path covered by the body. That is the distance. Now this is distance according to the definition. Distance, the total path covered by the body. Displacement means the shortest distance between initial and final positions, that is called displacement. So anyway body is initially at point A. Now this is the initial positions. Body final position of this body is okay at B. This is the final positions. What is the shortest path or shortest distance between initial and final positions? That is called displacement. Now this is the displacement. Okay, displacement. Now the shortest path between initial and final position, displacement. Now the total path length is called distance. Let us see another example. So next another problem, another example. If a body is moving from A to B, body is moving from A to B, moving from A to B and then B to C as shown. Okay, now body is initially at point A. It is moving from A to B like this and B to C. This is the C position, C, point C, B to C. Now suppose consider this is a 3 meters and this is B to C, consider 4 meters. Now what is the initial position of this body? At A. What is the final position of the body? C. Initially body is moving from A to B, then after it is moving from B to C. Now what is the distance and displacement covered by the body in this case? Now distance means the total path length is called distance. Now distance, how can we measure the distance? Distance, that is the total path length. So total path length means A to B and B to C. So AB plus AB plus BC, that is the total path length, that is the distance. So what is the length of this AB? AB is 3 meters and BC is 4 meters. So 3 plus 4, 7 meters, that is the distance. 7 meters is the distance. Now next one is displacement. What is the displacement? The shortest distance between initial and final positions. So where is the initial position of the body? Initially is, this is the initial position. Point A is the initial position. Point C is the final position. What is the shortest distance between initial and final positions? So this is the initial position, final position. Now this is the shortest path or shortest distance. Now this is called displacement. Now this is the displacement, just like hypotenuse. Displacement. Now if we consider this is one right angle triangle, now this displacement is nothing but hypotenuse. So what is the hypotenuse value? Under root of side square plus side square, 3 square plus 4 square. Now this is the displacement. So displacement, that is equals to under root of, displacement, that is equals to under root of 3 square plus 4 square, that is, so how much we will get? Root 9 plus 16, that is root 25, that is the displacement is 5 meters. Displacement, that is a 5 meters. What is the distance covered by the body? Distance is 7 meters and the displacement is 5 meters. Let us see another example. So for example, if the body is moving in a circular path, a body is moving, a particle or body is moving in a circular path of radius r, moving in a circular path of radius or capital R. Now after one complete rotation, what is the distance or displacement covered by the body? After one complete rotation, so after one complete rotation, what is the distance or displacement covered by the body? Now the body is moving in a circular path, just like, initial position of the particle is A, it is moving in a circular path of radius. What is the radius of this circle? R, capital R. What is the distance and displacement covered by the body in this case? Now distance distance, that is equals to total path length, the total path in which it is moving in a circular path. The total path is nothing but circumference or perimeter of the circle. Now the radius is, if the radius is R, the circumference is 2 pi r, that is the distance covered by the body. Now what is the distance covered by the body after one complete rotation? That is a 2 pi r. Now what is the displacement? The displacement means the shortest distance between initial and final positions. Now initially body start at point A and moving in a circular path, and finally it reaches again same point A. Now here initial and final positions. Now initially start from A, it is moving in a circular path, and finally it reaches again same point. Now in this case, initial and final positions are coincide. There is no shortest path between initial and final positions. What is the reason here? Initial and final positions are coincide. That's why what is the distance between initial and final positions? That is a 0, because now here for initial and final positions are coincide. That's why the displacement covered by the body after complete one rotation, so that is equals 0. What is the distance covered by the body after one complete rotation? That is a 2 pi r. What is the displacement covered by the body after complete rotation? After one complete rotation, that is 0. Okay. Another example. If the body is moving in a semicircular path, if a body is moving in a semicircular path, now body is moving in a semicircular path from A to B like this. This is the initial position and this is the final position. Body is moving along this path. The semicircular path, radius of this semicircular path is r. So what is the radius of this semicircle? R. Now what is the distance and displacement covered by the body in this case? Now body is moving in a semicircular path, started at point A and reaches point B in semicircular path of radius capital R. Now what is the distance and displacement covered by the body in this case? Now the total path length is called distance. Now this is the total path length, this is the distance. This will become distance. What is the shortest distance between initial and final positions? So shortest distance between initial and final positions. This is the initial position, this is the final position. This is the shortest distance, the shortest path between initial and final positions. That's why displacement, in this case displacement that is equals to displacement that is equals to, so how much r plus from here to here r, from here to here r, the total path length, that is the total distance between initial and final positions, that will become 2r. Now distance, this is the distance, this is the displacement. Now what is the distance? Distance is equals to total path length. For complete circle, the total path length is 2 pi r. For complete circle, the total path length or circumference is 2 pi r. For semicircle, what is the total path length means? Half of the total value, 2 pi r by 2. How much will get? Pi r. Now this is the distance. What is the displacement covered by the body? Displacement that is equals to shortest distance between initial and final positions, that is r plus r to r. So that is the distance and displacement in case of semicircular path. When the body is moving in a semicircular path of radius r, the distance and displacement. Distance is a pi r and displacement is 2r. So now let us see another example. If the body completes 1.5 rotation or 2.5 rotation, now what is the distance and displacement covered by the body? For example, now consider another example. After 2.5 rotations, after 2.5 rotations or 1.5 rotation, what is the distance and displacement covered by the body? Okay, now distance, this is the first rotation, this is the one rotation, second rotation, and half rotation means semicircular path, half rotation. Now in this case, distance, what is the distance? One complete rotation, what is the distance covered by the body? One complete rotation, already we have discussed in the previous example. After one complete rotation, the distance covered by the body is 2 pi r. Now after second rotation, again one complete rotation, this is also one complete rotation. What is the distance covered by the body? That is also 2 pi r. Half rotation, semicircular path, what is the distance covered by the body? That is a pi r. So distance covered by the body is pi r, that will become pi r here. Now this is a pi r. Now the total distance covered by the body after 2.5 rotations, that is 2 pi r plus 2 pi r is plus pi r. The total value is 5 pi r, that is the distance covered by the body. Now what is the displacement? In this case, displacement covered by the body after 2.5 rotations. After one complete rotation, initial and final positions are coincide. Due to that reason, displacement will become 0. After one rotation, displacement is 0. After second rotation is also, displacement will become 0 because it is also one complete rotation. Half rotation means semicircular path. If it is complete one semicircular path, what is the displacement? Displacement is 2r. So this is a 2r. This is a 2r. 0 plus 0, 2r means 2r. That is displacement. After 2.5 rotations, what is the distance covered by the body? That is 5 pi r. Okay. Now what is the displacement covered by the body? 2r. Okay. Let us see another example. If body completes, okay, moving in a circular path, if it completes an arc, it traces some arc. A body is moving. Another example, a body is moving in a circular path of radius, circular path, arc of circular path of radius capital R, like this. Now this one complete circle, but body is moving from A to B, it traces some arc. In case of arc, right, body is moving from A to B, okay. It traces arc of radius capital R. This makes an angle theta at the center of the circle. Now body is moving from A to B along the arc of radius capital R. It makes some angle theta at the center of circle. Okay. So what is the distance and displacement covered by the body? In the previous case, we have discussed about for complete circle and semicircle. For complete circle already we have discussed, and semicircle also we have discussed. But in case of arc, what is the distance and displacement covered by the body? Okay. So now this is arc. Okay, arc means a part of circle. Okay, this is arc, or we can write arc length. Arc length. The total path length is nothing but here arc length. This is the total path length covered by the body, that is arc here. So now this arc length we can consider as a distance. Distance means the total path length. The total path length means this is the path followed by the body or particle. Now this is also considered as an arc. Okay, now here arc length is nothing but distance covered by the body. What is the displacement covered by the body? Displacement means the shortest distance between initial and final positions. Now this is the initial position, this is the final position. The shortest distance between initial and final positions means this is the shortest distance, like this. Now this is the shortest path. That shortest path is called displacement. So we have to measure here what is the distance and displacement covered by the body when it traces arc, when it is moving in a semicircular arc of radius capital R. This is the radius of the semicircular arc. Okay. Right. Now, what is the relation between radius and arc length and angle theta? Angle theta is equals to, we have one formula, angle theta equals to arc length by radius. Okay, what is arc length? Arc length that we can write, arc length that is equals to, so angle theta into radius r. Radius means that is a capital R into angle theta. Okay, so arc length is called as distance. Anyway, the distance covered by the body when it is moving in a arc, okay, arc of radius r, that distance is equals to r into theta, where theta we have to consider in radian, theta, where theta in radians. Okay, consider in radians. Right. Next, what is the displacement? What is the displacement covered by the body if the body is moving in a arc, along the arc? Now, to find the displacement, consider a perpendicular bisector. Now this is one or complete circle. This is a complete circle. Body is moving only along the arc. This is the initial position, this is the final position. This makes an angle theta at the center, right? Okay, this point O consider, this is the radius r, B, right? This is a displacement. To find the displacement, consider one angular bisector. Angular bisector means this line divide two equal angles. Now the total angle theta means this angle will become theta by 2, this angle will become theta by 2. Total angle is theta. Actually total angle, that is the theta. Now consider one perpendicular bisector, it divides two equal angles. Now this midpoint is considered C. Now this is AOC, this is one right angle triangle, and BOC is also another right angle triangle. So apply sine angle for this right angle triangle. Okay, so here one right angle triangle AOC. Okay, AOC, apply sine theta, sine angle, sine theta by 2, that is equals to opposite by hypotenuse. Here hypotenuse is radius, so opposite, what is opposite value? AC by hypotenuse is radius. Now what is the value of AC? AC equals to r sine theta by 2. Now similarly for this right angle triangle, we have another right angle triangle. Now BOC. For triangle, this is one right angle triangle, apply sine angle, sine theta by 2. Now sine theta by 2. So for this theta by 2, this is the opposite, this is the hypotenuse. Opposite is CB, hypotenuse, what is the hypotenuse value? That is the radius. Now CB by radius r. Now CB is equals to r sine theta by 2, r sine theta by 2. So anyway, what is the displacement here? This is the displacement. Now this is displacement. This displacement will become displacement that is equals to AC plus CB, AC plus CB. Displacement that is equals to AC plus CB. Now, what is the displacement covered by the body in this case? Displacement that is equals to AC plus CB. What is the AC value? So, from this AC value is r sin theta by 2 and CB value is r sin theta by 2. So, now r sin theta by 2 plus r sin theta by 2, r sin theta by 2. Now, what is the formula? 2r sin theta by 2. Now that is a displacement. Remember directly this formula. When the body is moving in a arc of radius r and it makes an angle theta, what is the distance? Distance formula is r theta and displacement formula is 2r sin theta by 2. Okay, r is the radius of the arc, radius of arc. Theta is angle made by the arc. Now what is the distance formula? R theta. Now here theta is considered in radians. For example, theta equals to 60 degrees. What is the theta value in radians? That value will become pi by 3 radians. Pi by 3 radians. Now what is the displacement covered by the body? That is a 2r sin theta by 2. So based on this one, we will discuss one example problem. So let us see some example. Now a body is moving from A to B along the arc of radius 2 meters. It makes an angle 60 degree at the center of this circle. Okay. So now it covers only arc. An arc, it not complete circle, not complete semicircle. Okay, it raise some angle. Okay, some angle theta. It is moving along the arc of angle 60 degree. So what is the distance and displacement covered by the body? Distance and displacement covered by the body. In this case, already we have derived. So what is the distance formula, displacement formula? So when the body is moving in a arc, distance formula is r theta. So what is the r value? R is the radius. So a given value, radius r equals to 2 meters, and theta, what is the angle made by the r? That is a 60 degree. So in this case, r theta should be considered in radians. So what is the equivalent radians? That is pi by 3. 60 degree, that is equals to pi by 3 radians. Now what is the distance? Distance formula, r theta, r value, what is r value? 2 meters, radians, that is a pi by 3. 2 pi by 3, that is distance. This is in meters. If you want to substitute, pi value is also 2 by 3. So what is a pi value? Where pi is a 3.14 value. Okay, so that is a meters distance. By solving, we'll get a distance value meters. And what is the displacement? Displacement formula. What is the displacement in case of arc? So we have derived one formula, 2r sin theta by 2. 2r sin theta by 2. So what is the r value? R is a 2 meters. Now sin theta, what is the angle made by the arc? That is a 60 degree. Theta is a 60 degree. 60 by 2 means 30. So 2 into 2, 4 sin 30. Sin 30 value is 2. Okay, 1 by 2, sorry, 1 by 2. 2 1 times 2, 2 times 2 meters. That is the displacement covered by the body. In case of arc, okay, if a body is moving along the arc of radius r and it makes angle theta at the center. So what is the distance formula? Distance is r theta. So remember this formula directly. We need not derive again. Okay, so to solve the problem, remember formula. So what is the displacement in case of arc? That is a 2r sin theta by 2. 2r sin theta by 2. That is a displacement. Distance means r theta. For more videos, please subscribe My Dreamz Academy YouTube channel.